Section 10.6, Example 2 on page 631, we have some properties of equality have corresponding properties of congruence. The reflexive property for congruence says that segment AB is congruent to segment AB. So a segment is congruent to itself. We also have angle A is congruent to angle A, so an angle can be congruent to itself. The symmetric property says if segment AB is congruent to segment CD, then segment CD is congruent to segment AB. So we can switch the order of the segments. We can do the same thing for angles. If angle A is congruent to angle B, then angle B is congruent to angle A. For the transitive property, we have if segment AB is congruent to segment CD and segment CD is congruent to segment EF, then segment AB is congruent to segment EF. So again, this is sort of like using what we would think of as a substitution property to combine these two statements. We have a similar idea for angles. If angle A is congruent to angle B and angle B is congruent to angle C, then angle A is congruent to angle C. We could also say if angle B is congruent to angle A and angle B is congruent to angle C, then angle A is congruent to angle C using both the symmetric and transitive property. Example 2 says, what is the name of the property of equality or congruence that justifies going from the first statement to the second statement? For part A, we have 2x plus 9 equals 19 and 2x equals 10. First, we can figure out what we did to get from the first statement to the second statement. Here we have subtracted 9 from both sides to get 9 minus 9 is a 0 pair, and we're left with just 2x, and 19 minus 9 gives us 10. This is the subtraction property of equality. Make sure you notice that we have an equal sign. These are equations, so we are using a property of equality here. Part B says angle O is congruent to angle W, and angle W is congruent to angle L. Angle O is congruent to angle L. We can rewrite the two statements using colors to help us identify what happened from the first statement to the second statement. So we had angle O is congruent to angle W, and then we used angle W again to say angle W is congruent to angle L, and then the final statement says angle O is congruent to angle L. So we can see that we had angle W twice and eliminated it to get angle O is congruent to angle L as our final statement, which was the transitive property of congruence. Again, make sure you pay attention to the symbol. Here we have congruence, not equality. For part C, we had measure of angle E is equal to the measure of angle T, and measure of angle T is equal to the measure of angle E. Again, we can rewrite the two statements and use colors to identify which property of equality or congruence was being used. So first we had measure of angle E is equal to measure of angle T, and then we had measure of angle T again is equal to, again, measure of angle E. This is just the symmetric property of equality because all we did was switch the order of the angle measures on each side of the equal sign. Also, make sure you pay attention to the fact that this says equals and not congruent. We can use both equal and congruent when we're talking about angles. When we talk about a measure, it's equal. When we talk about the angle itself, it's congruent. So this is the symmetric property of equality. The work for this problem is written out on the next few slides. And now I would like you to try homework number 3 and 4 on page 631. Name the property of equality or congruence that justifies going from the first statement to the second statement. For number 3, we have segment ST is congruent to segment QR, and segment QR is congruent to segment ST. And for number 4, we have the length of segment AB minus the length of segment BC is equal to 12, and the length of segment AB equals 12 plus the length of segment BC.